If I give you a whiteboard today and ask you to explain what does artificial intelligence mean or what does AI mean to one of your friends, what is the first thing that comes to your mind? Is that ChatGPT? Or is that Gemini? Or is that a math problem? Or probably robots or robotics? And that's the problem today. With so many buzzwords around us, AI probably means everything, and hence, it means nothing. In this video, I'm not going to give you any more buzzwords. Rather, I'll try to make sense of the existing buzzwords in the field of AI. And I'll try to explain them going not too much in detail, but detailed enough so that it starts making sense to you and you understand where each of these words lie into the spectrum of AI. And probably after that, words like deep learning, machine learning, supervised learning, unsupervised learning, etc. starts making more sense to you rather than sounding mysterious. So with that, let's get started and let's go to the board. I have seen people use the word AI or ML interchangeably, right? And fundamentally, these are absolutely different. And that's where I thought that let's create a map or a spectrum of this so that we understand where all these concepts kind of stay or lie so that we get a better idea of it, right? So let's start doing that. One of the good things about all these things, by the way, is that all these concepts like supervised learning, unsupervised learning, machine learning, deep learning, these are all related to the field of artificial intelligence, which is the father or mother of everything and sits at the top of our spectrum, right? And what is artificial intelligence? It's basically simulating human intelligence into machines, which means that we make machines do certain tasks that would have probably required human thinking. That's it. That's the example. Now, a subfield of this is called machine learning. Now, what is machine learning? So machine learning is basically this is where we develop algorithms to make computers learn to do certain tasks that will require human intervention, which is basically achieving artificial intelligence, right? And they do it by learning the data that is provided to them, the algorithms basically, and tries to figure out that can I learn from this data and can I take some decisions based on this data, right? And these algorithms kind of use something like a pattern matching or statistical analysis to come up with the decisions or predictions. Now, machine learning is, as a word or as a concept, is pretty broad. So what I will do right now is that let's park these things. That's the map that we started creating. We'll come back to this. But let's look at machine learning and its types, right? So machine learning, we are going to look at two different types of machine learning now. One is supervised learning and one is unsupervised learning. There is also reinforcement learning, and we'll come to that after we discuss these two, because these are the most common or most used types of machine learning that we have. Now, supervised learning is where the algorithm has labeled data, and unsupervised learning has unlabeled data. But what does this labeling or unlabeling actually mean, right? Let's try to decipher that. So when I say that a supervised model is basically having labeled data, that means the algorithm already knows what the correct output is. For example, I show it millions of pictures of cat or dog, and it knows what is a cat and what is a dog, right? And there are different subcategories of supervised learning as well, and let's look at two main subcategories. The first subcategory is called classification. Now, classification is, as the name says, is where the models actually can put outputs into two different classes. For example, let's say, or labels, right? In this case, for example, if you have received a mail, whether it's a spam or it's not a spam. If I have an Aadhaar card, I show it which is a fake Aadhaar card and what are the characteristics of a fake Aadhaar card and what are the characteristics of a real Aadhaar card, right? The second subcategory of supervised learning is called regression. Now, regression is the place where you will have a continuous set of predictions or probabilities, and often this is used in something like weather predictions or stock analysis, etc. Right? And there are different types of regressions like linear regressions, and we'll go in deeper later on this. So that's about the two categories. Now let's come to the unlabeled data, which is the unsupervised learning. What does unlabeling means? So this simply means that the training data set that is used to build these algorithms is basically built with unlabeled data, or there is no human or machines who actually categorized to show the algorithm that this data is a cat, this data is a dog, these are trees, or something like that. Instead, it looks at the data itself and tries to make sense out of it. One example could be something like, let's say there is a box of Legos and you have different colored Legos, different shapes of Legos, and you give it to this unsupervised model, and it tries to come up with correlation and tries to segregate them, right? So for example, it might choose to collect all similar colors Legos together and create a group out of it. There are three different areas mainly where unsupervised learning is used, right? And let's look at them one by one. The first one is called clustering. Now, clustering is basically where, again, it's related to bucketing. Let's say I give it certain set of data, and mostly you'll see this in customer segmentations, where it has the set of customer data from the CRM, and it tries to group those customers maybe according to age, locations, or something like spending habits, etc. The second usage of supervised learning will come in something called association. Now, association is very interesting. This is where it tries to identify relationship between different variables in a data set, right? And typically answers questions like, if a set of users bought this, they are also likely to buy that. And that a famous example comes to my mind, and you can Google about it. You can pause the video and Google about it if you want to go a little deeper. It's called diapers and beers. So diapers and beers sitting together sells the most, right? And this type of usage comes with association in unsupervised learning. And the last part is the last usage rather of unsupervised learning is on dimensional reduction. This is where it looks at a set of data and tries to remove certain variables from, or unwanted variables from this data, without losing the meat of the data or the actual context of the data. This you will mostly see happening in the in pre-processing stage of data, and mostly used in something like, let's say you have seen you have many applications in your phone which basically deblurs your images, or kind of takes away the noise from an image and gives you the clear picture. And if you have used some crappy ones, you will see that when you run this, like for example, deblur my photo, it will deblur it, but it will also take away a lot of the features of your face, right? Which is a poorly written dimensional reduction or usage of unsupervised learning. So these two, and I must say there is one in between these two as well, which is called semi-supervised learning, right? Where you have a small set of labeled data clubbed with a large set of unlabeled data. And the algorithm uses the labeled data set to generalize the unlabeled data set. Now, what is the benefit of this approach is that, labeling is costly. Whether a human does it or a machine does it, labeling each data and then feeding it to the algorithm is very costly. So what is happening here is that it takes away that cost a little bit. Also, if I have to take one major difference between supervised models and unsupervised models, or supervised learning and unsupervised learning, is that unsupervised models, or models which are prepared with unsupervised learning, cannot predict. They can only segregate the data, whereas your supervised model can predict. And we have seen this in the previous examples as well. Now, as I said, these are the two main types of machine learnings, but there's one more type of machine learning which is called reinforcement learning. And I'm pretty sure you would have seen this in the current context of, let's say, if you're using something like ChatGPT or Gemini, you would have seen that sometimes when you ask a question, it gives you two outputs, and it asks you to choose one that you like the most. And let's say you liked one of them, the subsequent responses are a little bit more catered to your taste, right? I don't know if you've faced this, but the next time you get two outputs, that is the reinforcement learning kind of kicking in, where there are two main aspects of reinforcement learning are there. One is state, where the model kind of observes its current state, right? What I have and what I'm providing, and based on that state, it tries to take certain actions, right? So, for example, here when it shows two outputs and you choose one, it starts thinking that my next responses, I need to add these things into my responses because the user has chosen this. And then the environment, or in this case it's you, either will reward that that action that the model has taken by putting a thumbs up into your response, or punish this action by putting a thumbs down. And this actually makes the model to learn a little bit further more, right? So that is what reinforcement learning is. Okay, so now let's go back and put these things into our map and then look at what is the next step, which is the deep learning, which is the reason why I'm into the field of AI, right? Okay, let's do that. So our spectrum started to look good, isn't it? So we have artificial intelligence, then we had machine learning. Inside machine learning, we had something like supervised, unsupervised, and reinforcement learning as well. So now comes deep learning. Now, deep learning is something very interesting. This is the reason why I came to the field as well. This is where we try to mimic how our brains work by creating something called artificial neural networks. So right from our childhood, when we start seeing objects or start hearing some words or start seeing things in front of us, our brain tries to create that entity relationship between these two. For example, if I see an apple as a kid, people tell me, hey, this is an apple. So my brain kind of takes an image of this apple and also tags it as apple. After a few days, we come to know that apple is a fruit, right? And this is where our network kind of gets built over everything that we hear, everything that we see. Our neurons kind of starts working on creation of this entity relationship, right? The similar way in deep learning, it deals with lot of unstructured data. Now, there are three types of data in this point. If I can just basically talk about those. So you have structured data, which is mainly something like your DB, your MongoDB, your SQL DB, where you have data very structured in a way. Your Excels are very structured data. Then you have unstructured data like PDF or an image or a PDF with infographics in it, or a video, something like this. These are all unstructured data. And then you have something called semi-structured data. Now, semi-structured data is something like JSON or an XML, which are combination of both, right? So deep learning is kind of deals with the unstructured set of data, and it looks at the unstructured data, and how we train is by creation of those artificial neural networks. And this is how we try to create that link between two words in certain way in a form of entity relationship. So now you can imagine that all the data that was fed to something like a GPT 4.0 or GPT 5.2 today, or Gemini, the entire neural network, the artificial neural network, basically looks like a net, right? Yet when you go to something like ChatGPT and ask a question like, hey, I bought an apple for 1,50,000 rupees, it quickly knows that you are talking about iPhone from the company Apple and not Apple the fruit within a split of seconds. How does this happen, right? And it exactly happens how our brain also works, right? And this is where the deep learning kind of comes in. Now, there is another concept, or there's another type of models called foundation models, which are basically, I think, popularized in the year of 2021 by Stanford University. And this foundation model falls under the area of deep learning. Now, the foundation models are basically large-scale artificial neural networks which are trained on something like a large scale of data, and kind of provides the foundation for many applications at the top of it, right? And you have seen people like Mark Zuckerberg from Facebook, Meta, kind of releasing open source models like Llama. Before that, it was Alpaca 3-4 years back. Now, this foundation models actually kind of, if you get an open source, like if people if you get an open source model, this saves you a lot of cost to train a new model, right? And when I say cost, I just don't mean cost in the terms of dollars or rupees. I mean from the perspective of carbon emissions that happens because these machines are running for a long period of time. Instead, you can take one of those foundation pre-trained models and fine-tune your data at the top of it, which basically saves a lot of money, lot of energy in this world, right? And I think there is one layer below, a specific type of foundation model I have to talk about, and I have to put that into the spectrum. It's called large language models, or LLMs, and I'm pretty sure all of us have heard about it, which is a foundation model which specializes in generating text, human-like text, right? And these are processed around a lot of textual information, right? And last but not the least, let me talk about one more term which all of us again would have heard about. Is called generative AI. Now, if I try to take a difference between foundation model and generative AI, so while foundation models kind of provide the underlying structure and knowledge or understanding of the data that is given to it, generative AI is the way which kind of uses those knowledge to create something new, right? Which is true for text, to generate something new text. Hey, can you write a poem for me where every word starts with A and it has to be creative? Or can you generate a picture of a cat wearing a formal dress, which is an image? Or can you generate a video, right? So all these are part of generative AI, right? So that's our spectrum for now, and I hope all these buzzwords that we have been listening to kind of falls into a structure for you right now, and it started to make more sense, right? And we'll go a lot deeper into a lot of other videos as well, but let's start with this one, which is the foundation, and we'll talk about a lot more things in future videos as well. For example, as I was saying in the last line, in perspective of generative AI, that hey, can you create when you go to ChatGPT and ask a question that, hey, can you create a poem where every word starts with A, and it kind of goes ahead and does that very beautifully. It's being creative, right? And these models are supposed to be creative. And as human, ask yourself, when you are trying to innovate, when you are trying to be creative, what do? You basically try to imagine something that does not exist today and try to build that, right? In another term, you are also hallucinating when you try to innovate, right? So when you try to be creative, you hallucinate. And these models, like all the models which is under the era of generative AI, is by design supposed to be hallucinating. And here we are trying to control that. So we'll learn a lot more about that. But as of now, I hope this video kind of gives you that important understanding of the terms and concepts and where they lie in that spectrum of AI. Thank you so much for your time, and I will see you in the next video.